know what the shift is, and once we know what the what's it called? Once we know what the shift is, once we know what the stretch is, right? There's actually easy, quick ways to graph it really quickly and sketch it. So we're gonna be going through those one by one to make sure we fully understand like what's going on. So here, with the sine function transformations, let's recall our terminology. So from the quiz, we had a couple issues with the period, right? So when I asked what is the period, like around half the class got it and half the class didn't for the first question. But for the second question, where it was like that Ferris wheel thing, where Mr. Choi's on his Ferris wheel, and for some reason the title of the graph said Trevor, uh, for that one, most of you actually got the period right, which means you guys are actually getting the period when it's sinusoidal, but when it looks like a weird pattern, something's a little bit off there. So remember, the period is how long it takes to repeat. So you look at a section and how long is that x? Where does it start and where does it end, right? Where does x start? Where does x end? And that gap is your period. So that's going to be the length between the cycles. We have the axis of the curve or the equation of the axis, right? Which is that middle point of our graph. So when we look at a sinusoidal function like this, it's y equals 0, right? Don't just write 0. Try to write y equals and then the number. And if you're using the formula, you have y equals at the front, so it doesn't matter, right? Max plus min divided by 2. We know that. So it's at the front, y equals max plus min over 2 equals, and then you just solve it. So y equals that value is going to be your equation of the axis there, okay? The amplitude, right? The amplitude is from that middle point, from that middle line, the equation of the axis, how far is it to go up, okay? And how far is it to go down? It should be equal, right? How much it goes up and how much it goes down should be equal for a sinusoidal function. Okay, so that's really important there. So what's the amplitude? How much up, how much down? And last but not least, your general equation. So we normally have, f of x or y equals sine x, but now instead of x, we put in theta. It doesn't really matter. You can put x still. Sine theta plus b plus d. And b is your phase shift, and it's in the same position as it was in the quadratic formula. If you remember from the quadratic formula, I'm just going to write it down on the side here. From the quadratic formula, we had y is equal to a x minus h squared plus d, right? We had this. Yes, I am recording. So y is equal to a bracket x minus h squared plus d. Notice how your horizontal shift is inside the bracket, just like before. So the position of vertical shift and horizontal shift in the equation is exactly the same from what you've seen previously. So you saw in the quadratics, vertical shifts on the very outside, on the right, outside of the bracket. So it's the same thing for the sinusoidal function. Horizontal shift is going to be inside the bracket, just like the quadratic equation. The other way we say horizontal shift is phase shift. You can choose whichever one you want to use. I don't mind whether you call it horizontal shift or phase shift. It just denotes the same thing. Okay. So the reason why this is a lot easier than you think is because, well, these points are absolutely wrong. Whoopsies. There is an error here. It should not be 90, 0. This should be 91. I apologize. So this should be 90, comma 1. So 0, 0, 90, comma 1, 180, comma 0, 270, comma negative 1, and then 360, comma 0. Sorry, a couple typos here. These are the 5 key points. And the reason why graphing and transforming sinusoidal functions are easier is because of these 5 points. In quadratics, we had to remember, the 1-3-5 rule and converting that, and it got complicated. And so I said, hey, forget that. Once you memorize these 5 points, right, things become a lot easier than you think. Okay? The main things that are the most important here are the x values. Okay? It goes up by 90 every time. So 0, 90, 180, 270, 360. So if you remember those 5 x values, the phase shifting becomes a lot easier than you think. Okay? So let's keep that in mind as we move on into these transformations. Okay? So we're always going to come back to these 5 key points. So this is really important. So in order to sketch a transformation, right, we simply transform the original points above, 5 points above, and to their new locations, and then join the points, right? So remember, if the b value is subtracting, it shifts. If it's positive, it shifts to the right. If it's negative, it shifts to the left, right? It's that whole thing. Sorry, positive shifts to the left, negative shifts to the right. That whole thing. Remember how we said, like, when we have x plus 2, this is actually negative 2, right? It's to the left. Same idea applies here. So nothing's changing. The rules, the exact same rules we had before are the exact same rules we're going to have now. Okay? So the rules are exactly the same. Nothing changes. This is me trying to make sure that we're not, I'm letting you know, we are just reviewing and doing the exact same thing we've done before. Okay? That's all you have to worry about. All right? So then the D value is the shift up and down. Okay? The D value is shifting up and down. Okay? So the first way we're going to learn it is going to be using the quick, understanding, hey, what's my phase shift? What's my D value? And what does the point turn into? So this is kind of like the rough method of doing it. There's no other shortcut to doing it this way. Phase shift is always going to have to be like, you're going to have to add and subtract these values. For vertical shift, there is a shortcut, and I'm going to teach you that when we move on to 6.6, which is right after this. Right? When we move on to 6.6, I'm going to teach you how to use the shortcut method to make this a little bit faster. So first, let's list the transformations here. We have a positive 45 inside the bracket. And positive 45 means it shifts to the left. So it's a phase shift left by 45 degrees. Right? And is there a vertical shift? No, no vertical shift. There's no vertical shift here. So the only thing we're working with here is a phase shift. So with the phase shift, it's to the left, right? Because it was positive, and theta equals 45. Or sorry, theta minus 45 is what we're going with here. Okay, so we're doing theta minus 45. So since we're moving to the left, we are subtracting. So 0 minus 45 would give us negative 45. Okay, and then this is plus 0 because nothing changes. So y is going to be 0. And so my transformed point is negative 45, comma 0. Just like that. And we do that for each one. So 90 minus 45 is going to be 45. 1 plus 0 is going to be 1. So my transformed point is 45, comma 1. If for those that are confused as to what I'm doing, once again, I'm doing this. I'm taking my x value or my theta value here, and I'm subtracting 45 because we're shifting to the left. Okay. So same thing happens here, 180 minus 45. That's going to give us 135, and 0 plus 0 is just 0, and that gives us our next point. So 135, comma 0. Continuing onwards here, 270 minus 45 is going to give us 225, and that's going to be -1. So that's going to be 225 comma -1. And the last one here, 360 minus 45 is equal to 315. And that's going to be 0. Just like that. So the math that we've done before with transforming these doesn't really change, right? If it's shifting left, you move it to the left by whatever the value is, right? That's all it is. That's all there is to it. Nothing fancy about it. That's pretty much it. Okay, so I'm going to let people copy that down real quick, and then we're going to move onwards.
Can you move a little bit up, Mr. Choi?
Yeah, I can zoom out a little bit. Let me zoom out, and then shift it up. Okay. So then it says state the domain and range of the new curve. Okay. So all you have to worry about domain and range, right? I think people would like a quick, I guess, I don't want to say shortcut, but I guess a quick way of identifying domain and range. Domain, there's not much to say other than if you have a lower and upper limit for the x value, right? That's what your domain's going to be. So if we say for the domain here, start with XER such that, and what's the lower limit? It's going to be -45. That's the lowest x value that we start at, is less than or equal to x, which is less than or equal to, and the highest one, 315. Okay. Some people got these signs wrong. Remember, if there's two, there's a lower and an upper limit. We're doing the same less than or equal to sign. For the range, I'm going to give you a little bit of a hint here, or like a quick tip. It's the trough less than or equal to y, which is less than or equal to the peak. Hopefully that kind of narrows it down for you or helps you a little bit more. So if you can identify the trough and the peak, that's pretty much what your range is. So if we do it for this one, it's YER such that -1 is less than or equal to y, which is less than or equal to 1. Does that help? Hopefully that helps. So this is always going to be the range, right? Your trough and your peak. If I can identify the highest point and the lowest point, that's essentially your range. Okay, max and min, or min and max. And then the equation of the axis, where's the middle? Well, the middle is just 0. It hasn't changed, right? The middle of this graph is still going to be at 0. We haven't, if we didn't shift it up and down, the middle of the graph shouldn't change, right? There's no reason the middle should change if we've not moved it. So the equation of the axis is still y equals 0. Any questions so far on this information here? All right, no questions here, so we are going to move on. So now I want you to try this one. For question 2a, I'm going to give you an example, and 2b, I want you to try yourself. Write the equation that goes through these transformations. So it says horizontal translation of 20 degrees to the right and vertical translations 3 units up. So for me, this equation would be y is equal to sine theta minus 20, plus 3. That will be my first one, right? 20 degrees to the right, which means it's minus inside the bracket, and then 3 units up would be plus 3.
Wait, mister, so if it's right, it's negative. If it's left, it's positive.
Yeah, same thing that we did before.
Okay.
Same rule. So try 2b. Give you a minute to think about it and write it down, and we'll take it up. Okay. Your equation should be y is equal to sine theta plus 35 minus 5. If you got that, done. You are able to identify horizontal shift and vertical shift, no problem, inside an equation, and are able to put it in. Right? Nothing too bad. Nothing too bad. So then let's dive into sketching it. So this time we're taking the sine theta plus 45. It's the same thing, right? And now we have a vertical shift to it, down by 3. Okay? So it says we need to indicate domain, range, amplitude, phase shift, vertical shift, equation of the axis, right? We got to write all of that kind of stuff here down here. So we're going to be doing that, and then we're going to graph it on the next page if you're able to graph it, if you're able to print it out. If you were unable to graph it, don't worry about it. We'll just work with what we got. Okay? So phase shift, it's to the left. So it's minus 45, right? So if it's plus 45, we're actually subtracting. And then for the y, it's down, so it's going to be minus 3. Right? So we write that information in, and then we do the math. 0 minus 45 equals negative 45. I'm just going to do all the x ones. These are the exact same as the ones we did before, right? Because we're moving to the left by 45 again. So I'm just going to quickly write it again. Okay. So that's going to be our phase shifts here. For the vertical shift, right, we take our y value and we do exactly as it tells us. So it's minus 3. So 0 minus 3 is negative 3. 1 minus 3 is negative 2. 0 minus 3 is negative 3. Negative 1 minus 3 is negative 4. And 0 minus 3 is negative 3. Once we have all of our shifts down, we can then figure out what our points are. So negative 45 comma negative 3, 45 comma negative 2, 135 comma negative 3, 225 comma negative 4, and 315 comma negative 3. So these are our points here. Okay. All right. Any questions about these calculations here? It's literally brute forcing it, right? It's just table of values. If it's left, you subtract. If it's right, you add. If it's up, you add. Down, you subtract. Literally doing all these calculations and then getting your point. So it's, once again, nothing new. The math is nothing new. The only thing new about it is literally the fact that it's a sinusoidal function. That's it. That's the only thing that makes it new. So I don't want you to freak out when we're learning this content here. I want you to feel more comfortable thinking the fact that I've done this before. It's just with a couple of new points, and that's it. Okay. So then, does anyone want to give some of these a try? Domain. Anyone want to give the domain a try? I think this one's easy. Yes, Brooke, go for it.
XER such that negative 45 is less than or equal to X, which is less than or equal to 315.
Perfect. Right? Like what Brooke said here, negative 45 less than or equal to X less than or equal to 315. That's going to be our biggest X value and our lowest X value. That's correct there. I'm going to shift that over just a little bit because I wrote too big. Okay, and the next one here, the range. Anyone want to give range a shot? Anyone at all? I'll get you started. It's YER. We just need the restrictions. Not -3. That's not the lowest value. -4 is our lowest value. Less than or equal to y, which is less than or equal to -2. Perfect. Thank you, Christian and Brooke. So that's going to be our range for this one. -4 to -2. So we have our lowest value and then we have our highest value, right? So that's going to be our peak and trough. And so we put that into our range. Anyone with the amplitude?
Can I,
What's the amplitude? Sorry, Lauren?
can I try?
Yep.
I got +1.
Yes, +1 is correct. Amplitude is 1. So if you wanted to calculate it, you can calculate it as well. Max minus min. So -2 minus -4 divided by 2 will give us -2 plus 4, which gives us 1 actually. So 2 divided by 2 is 1. So yes, amplitude is correct. Lorraine, with that. Phase shift. Well, we know what it is. We said left by 45. Vertical shift was down by 3. Just to make it simple there. And you'll want to give equation of the axis here. And you want to give that a shot.
Is it 0?
No, it is not 0.
-3?
Yes, -3 is the answer. Where the middle is going to be -3. And for those that are curious, how can we get that faster? I think you guys can quickly identify that. You'll notice the 3 points that were already on the equation of the axis for the original are these 3 points, which means when they get transformed, they should still be in the middle. Does that make sense? Right? So these 3 points are in the middle of our graph, and I'll show you that on the next page here. If they're in the middle for the graph, they should be in the middle when they're transformed. So you'll see that here. Now let's graph it, and you'll see here the 3 points I'm talking about are here, here, and here. Notice how they're exactly in the middle, right? Where the equation of the axis is. So when we transform it, you should be able to identify that. Now, what's the easiest way to graph this? Because this seems like a pain to graph. So what you do here, listen very carefully. The first thing I want you to do when you graph this is to graph the equation of the axis. So I'm going to graph y equals -3. And so I'm just going to draw a long horizontal line and y equals -3. Okay? So I purposely do that because that's going to tell me, oh, that's where the middle of my graph is. I should be looking there. So we have y equals -3 there. Okay? And then, once we have that down, we then look at all of our x values and we can mark those down as well. So -45 and -3. Now that I know that where -3 is, I just need to find -45, which is 10, 20, 30, 40, so it'd be around here. So I'd say that would be my first point. And so this would be -45, -3. Maybe I want to do that with a thinner stroke. So -45, I'll just zoom in. So -45, -3. Just like that. And then our next one, we scroll back up here. Actually, let's not scroll back up. That's kind of a pain. I'm just going to take a snapshot of this. Bring it over here. Okay, so our next one was 45 and -2. So we find 10, 20, 30, 40, 45, and we find -2. And there's our next point. It's a sketch, doesn't have to be super accurate. You can yell at me for saying that's not 45, Mr. Choi. You're a terrible, terrible grapher. I get it. I'm sorry. I'll do better next time. Sorry, that's supposed to be negative. So 45, -2. Our next point after that was 135 and -3. So 100, 110, 120, 130, 135, and -3 somewhere around here. So that's going to be 135, -3. And our next one after that is 225 and -4. So 10, 20, 30, 40. Oh, sorry. Whoopsies. 10, 20, 25. I don't know why I was going all the way to 40. All the way down. And we're going to go until we hit -4, which is right here. So that's going to be 225 and -4. And then our last one is 315, -3. So 310, 20. Sorry, 310, 15. Wow, mornings. Terrible. And that's going to be our last point. So 315, comma, -3. Just like that. So there's our 5 key points. And now all that's left is to draw a beautiful curve, which I cannot do. Why am I drawing it with a line? So you just connect all the dots with a nice curve like this, and voila, as best as I could, right? Not the most accurate curve, but it'll get the job done. It's a sketch. Sketch doesn't mean it has to be perfectly accurate. It's a rough drawing. The main things I want to see are the 5 points, just like this. Okay? So once you get your 5 points, you're good. Okay? Any questions on this sketching part here? So I'll leave it here. Once again, the 5 key points on this graph would be these 5. So we've transformed these 5 red points into these 5 blue points. Essentially is what we've done. And you'll notice by drawing the equation of the axis, we don't have to constantly look for -3. We know where we're looking at. So drawing that equation of the axis really helps us focus on literally just focusing on where the x values are, because that's going to be the most annoying when I give you a graph like this, right? So just focus on, hey, where's my x-axis? After you draw the equation of the axis, makes it a lot easier to work with. Okay? So that moves us on into the next one, which is 6.6. That was 6.5. So that was vertical shift and horizontal shift. right? So hopefully people are getting like, oh, I'm starting to remember. I kind of get it, right? I'm kind of understanding like where the shifts work, which is good. The one thing that people hated that I remember is vertical stretch and compression, because you had to do the whole 1-3-5 rule. It has to be thinner and wider. Like, oh god, that was such a pain to work with and remember. It was just confusing, and I understand. You're in luck. For sinusoidal functions, actually, the vertical stretch slash compression is actually much easier. So once again, this is another typo that I should have fixed. Sorry. So that should be 1 and that should be -1 here. Okay. And I'm going to teach you something. Yeah. So I would like everyone to pay attention for here. So once again, the terminology here, this was supposed to be separated into 2 days. That's why we have overall review of the terminology again. So you should know what the period is, equation of the axis, amplitude. But this time, of course, now we're sticking in our A value here, which is our stretch and compression, right? And the rules are the same. It's greater than 0 or greater than 1, it's a stretch. If it's less than 0, or sorry, if it's less than a fraction, right, between 1 and 0, it's compression. So if it's a fraction less than 1, that's going to be our compression. So I'm actually going to change that and say 0 less than A, which is less than 1. That's the more accurate one. I should change that. My apologies. So 0 less than A less than 1 is compression. Okay, so that's really important here. But I'm going to give you something else. Everyone should write this down. So I'm going to copy down the equation again. Y is equal to A sine. I'm going to write X plus B plus D. There are 2 things that I want you to remember here. And this is going to save your lives. I promise you this. The A value is the amplitude. The D value is the equation of the axis. This is going to save you a ton of time, right? By understanding where the equation of the axis is and what the amplitude is, you can actually draw 3 lines that shows you middle, top, and bottom. And that will make your lives a lot easier when you start graphing it and speed graphing it. So that everyone should be copying this down. This is super important. Okay? The A value of your sinusoidal function is literally the amplitude. And the D value is literally the equation of the axis. Nothing changes. Whatever value you see there is exactly the value you want to use. Okay? So let's dive into it. Let's figure out how that works, right? And how we can graph it quicker. Okay? So subtract the B value to theta, left and right. Multiplying the Y value by A is a stretch compression. If there's a reflection, you'll see it. And then you add the D value, right? To shift it up and down. So we're gonna go through once again. The first way we're gonna go through is the like the brute force method, right? So when we brute force it, we're gonna actually calculate all our values. But then when we do it the second time, I'm gonna show you brute force as well as just identifying, and we're just gonna sketch it as best as we can using our quick way of identifying equation of the axis and amplitude. That's going to save us a lot of time. Okay? So, the brute force method, because we do need to learn this, right? List the transformations. What transformations do we have here? Anyone want to give it a shot?
Can I try?
Yes, you may.
It's vertical stretch by 2 and face shift to left.
Vertical stretch by factor of 2, and then you said phase shift left by 45 degrees. Yes? Perfect. That's what Lorraine said, and that looks right to me. No issues there from me. There is no vertical shift here, and since the value at the front is 2, it's positive 2. So then we have to complete the table. So now let's do this rough work here, right, where we're going to brute force the calculations. So we said it's a shift left by 45, so we're going to subtract 45 here. It's a stretch / compression. We know it's a stretch. There is no reflection because it's not negative. So we're going to multiply the y value by 2. And the vertical shift, there is no vertical shift. So we can actually ignore this, right? We know there's 0. So we can just say plus 0, if anything. So what's going to happen here? Once again, 0 minus 45. I don't think I need, do I need to go through these calculations again? You guys know, right? I think we're good. Please tell me we're good. Do you have to do all these again? It's the same values as before. It's minus 45, so I'm just gonna quickly do it, just to save us some time. So bear with me here. 225 and then 315. Okay, so these are the x values that we know, like the theta values that we know. We've done it twice already. I'm just gonna copy it down again. The stretch and compression part, this one here, so we're gonna do 0 times 2, which is equal to 0. 1 times 2. I'm going to put that closer to the middle so it's multiplying. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And then 0 times 2 is 0. Okay? Nothing happens here because it's plus 0, so it doesn't matter. So this would be our transformed point. Oopsies, that's 0. Okay. So now, once we have these transform points, I'm going to let people copy it down for a little bit. All right, moving onwards. Domain and range. Let's try to get someone that's not Christian, Brooke, or Lorraine this time. Would anyone else like to give this a shot? Domain's easy. We've done this. If you listen to the lesson so far, this domain should be free. No one wants to give domain a shot? Do I have to pick a random person? Don't make me pick. I hate picking. And count down.
Sir, can I go?
Yeah, go for it.
Okay. XER
Yep.
negative 45 less than or equal x less than or equal 315.
Perfect. Thank you very much. That is definitely the domain. Thank you. That's perfect. Anyone want to give range a shot? Once again, if you've already answered, I would ask you to refrain from answering for now. Anyone? Come on, getting it, like, this is okay to try. All right, I'm gonna pick someone at random. All right, Google. We got 22 people in this class. Lucky number 19 is going to be Sophia. Sophia, what is the range for this set of points that we have here? I'll zoom out a little bit so you can see the whole thing. What's the range here? All right, looks like we don't got anybody. Sophia, I don't think wants to answer. So let's keep going here. YER such that the lowest value is -2, the highest value is 2. So it'll be -2 less than or equal to y, which is less than or equal to 2. That's the range. Okay, so make sure you get the practice with that, understanding what domain and range is. Equation of the axis. Once again, let's go through that shortcut, which we said it's the plus d value, which means, was there a plus d value here? No, which means it's 0, which means the equation of the axis is 0. Very easy to find. Right? Once we figure those rules out, much easier to identify these things. Right? Quick and easy, boom. Okay? One more time for questions. Any questions so far on this content? What I want you to understand here is, can you find the points? Can you graph it? Can you find the transformations? Can you graph it? Right? Yes, you will have to graph for your test. You have to. You have to. Okay? You must be able to graph for your test because there will be graphing questions. Next, moving on. Let's make sure we have this down. I'm going to give you 3 minutes to write the equations for questions 2A and 2B, and I will pick 2 people at random. I'll pick 2 people at random to give me the equations. Okay? So I'll give you 3 minutes to do that, and during those 3 minutes, I'm going to take attendance because I didn't do so yet. Okay. Time is up. Random number generator. Here we go. 15. That is Kimberly. Kimberly, what is the first equation for 2a?
3 cent 0 minus 25 plus 3.
That looks good to me. 3 signed. Bracket theta minus 25 plus 3 looks good to me. Next up, let's go with 11. And that's Jonathan. Jonathan, what's the equation for the second one here? If you don't know, say that you don't know. Going once. Going twice. Once again, this is my best way of checking whether or not you are paying attention in class. All right. Next one up after that, let's see. We already did 19, which means Rena. Rena, are you able to respond with this one to B?
Yeah. Okay, so 0.5 sine 0 theta plus 35 minus 5.
Perfect. You're just missing one small thing. Everything's good. You're just missing one small thing.
What is it?
Anyone have an idea? Anyone want to help her out? Everything looks good so far.
Negative 0.5.
Negative 0.5. And the reason for that is that reflection. So, Rena, that was actually really good. Literally everything was perfect. Just that last part, which was the reflection, just need to stick a negative on there. How much would you lose? Probably a 0.5 or maybe a mark if I'm literally just doing each transformation. Don't worry. I think that was pretty good. You guys, the people that answered and the people that were able to support, very good. You guys have the idea of being able to identify where these numbers go in the equation, which is really what matters, right? That's the important part. You got the signs correct. You got their positions correct, right? And we didn't talk about reflections until now, so that's to be expected there. So we have our two equations here. Perfect. Make sure you try these. When I ask you to try it within the 3 minutes, don't just sit there staring at the screen. That's not the point, right? The point is to try it so that you know when you can see where you went wrong and where you did what you did right. So it's important for us to identify there. So number 3 here, we have a new equation. There's a brute force method using the table, but let's use what we did. Do you remember what we did, which was the whole hey, I know what the equation of the axis is. I know what the amplitude is. Can we figure out how to do this quickly? And the answer is yes. So here we have our plus 2. That's our equation of the axis. That you can write it right here. You don't even need to solve it anymore. Done. Equation of the axis, y equals 2, right? And boom, we have negative 3, but we only care about the positive number for the amplitude. The amplitude is 3. Okay? This saves us a lot of time. Okay? Just being able to do this saves us so much time. Okay? What that allows you to do here on your graph, what do you start off with? You start off with drawing the equation of the axis, y equals 2. So we're going to draw that out. That is not a line. That is a square. We're going to draw out x equals 2 there. Or sorry, y equals 2. That's our equation of the axis. You start with that. Then, maybe in blue, right, I'm going to do the amplitude. So what's 3 above the equation of the axis? That's 5. So I'm going to draw that right there. So what this tells me is that this line or the curve goes up to 5 and can go as low as 3 below 2, which is 1, 2, 3, which is -1. So see how quickly we can draw these lines here. So now we already have reference points on how to graph it. We know it should go as low as -1 and as high as 5, just from knowing the equation of the axis and the amplitude. Does that make sense? I hope that makes sense. If it doesn't, let me know. Right? So we draw the equation of the axis because that's the middle, and the amplitude is from the middle to the highest point, and from the middle to the lowest point, it's 3. It's a value of 3. So that's why we went 2 plus 3 is 5, and 2 minus 3 is -1. So that helps us out here. Okay? From there, what you can do is something very neat. Normally we start at 0, but we have a phase shift to the left to the right by 120. So we start at 120. That's right here. Okay? We start at 120. So we already have our first point. 120, comma 2. Because it has to start at the middle. From there, you can continue graphing it by using your key values. So 90 plus 120 is 210. And that's going to be at the bottom here because it's reflected. Okay, we have a vertical reflection, so it's going to go down first. Then it goes back to the middle. Now, some of you might be like, how the hell are you calculating so quickly, Mr. Choi? How the hell are you getting, how do you know it's 300? And it's not because I'm a math teacher. Let me explain. The phase shift, 120, is always going to be where the first point is. So since it's to the right by 120, it's going to start at 120. Correct? That's pretty simple. It starts in the middle at 120. Every point after that is 90 degrees apart. So what's 120 plus 90? 210. What's 210 plus 90? 300. What's 300 plus 90? 390. And what's 390 plus 90? 480. See how that works? Isn't that pretty good? I think that's pretty good. Right? I'm going to shift over this thing down a little bit lower actually. Oopsies. See how quickly you can graph it using that little tidbit of information? Okay, I actually need to erase it. I'm going to put it a little lower. Who liked that better? Some of you might like that better. Not sure. If you like that better, that's good. If you don't like this, that's okay. Do the brute force method. Do the calculations. And it works out. And we're going to go through that as well. So graphing this out, once we have that down, we're just going to connect the dots. And we're going to do something like this. And it looks stretched, right? Vertical stretch here. Boom. And there's your graph. Okay. So this is using that shortcut method I was talking to you about, right? Identifying equation of the axis, identifying the amplitude, then using the phase shift to determine where you start, and then just adding 90 to get your next few points. And then the reflection is something you have to keep in mind. If it's reflected, it goes down first. If it's normal, it goes up first.
Wait, Mr. Why is it 5 again?
So the equation of the axis is 2, right? Y equals 2 that we said before. And since the amplitude is 3,
yeah.
2 plus 3 is 5. And then 2 minus 3 is negative 1. So that's the lowest one. Okay? So that's going to give us our curve pretty quickly without having to do all those unnecessary calculations, in my opinion. So this is my personal way of quickly graphing it out. Okay? Some of you might be like, this seems like a lot. I prefer doing it the brute force method. That's fine. Let's go through that method, right? Let's go through it. Is anyone still copying this down? Are we good? All right, I think we're good. All right. Okay. So from here, let's brute force it this time. So looking here, we have our equation here. There is a phase shift. It's to the right. So we're going to add 120. Is there a stretch and compression? Yes, there is a stretch. Is there a reflection? Yes, it is negative. So we are multiplying by negative 3. The vertical shift, is there a vertical shift? Yes, it is up. So we're going to add 2 at the end of it. Okay, so let's go through each one here. Okay. So to start, we have 0 plus 120 is going to give us 120. So we take our theta value, our x value, we add 120 to it, we get 120. Our stretch slash compression here, we're going to start with 0 again, but we're going to multiply it by negative 3. Oh, what's 0 times negative 3? Well, that's 0. And so what does that work with? We then take that 0 and we're going to add 2 to it, and that's going to give us 2. So our final point is 120, comma 2. We take this and we take this. And that's going to give us our final transformed point. Let's do that for the next one. 90 plus 120 is equal to 210. So that's going to be our x. If you want to just write that down right away, I highly suggest doing so. Then we have our y value of 1, and we're going to multiply it by negative 3. And that's going to give us negative 3. We then take that value of negative 3 and we add 2 to it. And that's going to give us negative 1. And that's going to be our y value, negative 1. And so on and so forth. Continuing onwards in that same fashion. Okay. So on and so forth here. I'm going to speed up this process for my last 2 lines here. I'm just going to speed it up just a little bit. You should get 390 here. You should get 5 here. Or sorry, 3 here. And then you should get 3 plus 2. which will equal 5. And our last one, you get 480. You'll get 0, and then we get 0 plus 2. Okay. Domain and range. One more time. Picking new people again. Here we go. Random number generator. Number 12. Jozu. Domain, please. What is the domain of this sinusoidal function we have here?
Is it x is the element of real numbers such that x is less than or equal to 120, or x is greater than or equal to 120, but is less than or equal to 480.
Perfect. That's great. Thank you very much. Next person will give me the range, which is 11, but we did that. Oh, we'll see. Jonathan, are you back? All right, guess I'll mark Jonathan absent. Haley. Haley, what is the range? Oh, perfect. You already have it all typed up. It's like you knew I was going to call you out. -1 is less than or equal to y, which is less than or equal to 5, is correct. Thank you very much, Haley. Appreciate it. There's the range there. We already have the amplitude from before. The phase shift is right by 120. We said the vertical shift was up by 2, and there's the axis of the curve. And you can graph that, and you should get the exact same graph we got earlier.
Wait, mister, can you explain how you got the range again?
Remember, it's peak and trough. The lowest value goes first, highest value goes second. So as long as you identify the lowest and highest values, that's going to be your range. So we had that formula earlier. Hold on, let me bring it up here. The formula from earlier, which is why I want you to copy it down in case it helps, which was the range formula I mentioned. This one here. YER such that trough is less than or equal to y, which is less than or equal to the peak. So make sure you copy that down and keep that in mind, because this is going to be very helpful. Hopefully you guys found this a little bit easier than transformations during quadratics. Hopefully, that's the goal. It's not meant to be daunting. It literally is just identifying those key points, identifying equation of the axis and the amplitude. It helps you mark down where you need to look, what you need to worry about, and it makes the process a lot simpler than you think. Otherwise, that is it from me today. It's literally 10:20. I don't want to do anything more, but I do want to go over our schedule that's going to be happening for the month of May. Okay. So let's take a look at the month of May. Sorry, not May, June. I meant June. I'm going to stop.